All right, let's talk about the unit circle. So this is the unit circle. It's called the unit circle because the radius of it is 1 unit. So the distance from here to here is 1 unit, and technically this is drawn on a coordinate system. So this would be the origin. This point would be 1, 0. This point would be 0, 1. This point would be -1, 0, and this point would be 0, -1. Now, all these angles are pretty specific. We're going to talk about y in a second. That's a 30-degree angle, that's 45, that's 60, and the big ones are 90, which makes sense because it's on a coordinate system. But I'm not going to draw all those because it's going to get a bit clustered. I'm not really too keen on that. Anyway, let's talk about the angle measures. And this first angle is 0 degrees. Now, as far as higher maths are concerned, we don't really use degrees as much as radians. So I'm going to write in both degrees and radians so that you get sort of a better feel for converting between the two. So 0 degrees is the same as 0 radians, and sometimes to notate radians they'll put a little r in the exponent, but that's very, very, very rare. Older textbooks do that, the newer ones don't. So this angle, this first one, is a 30-degree angle, which is the same as pi over 6 radians. This next one is a 45-degree angle, which is the same as pi over 4 radians. This next one is a 60-degree angle, which is the same, 60 degrees, which is the same as pi over 3. And this last one is 90 degrees, well, last one in the first quadrant, at least. 90 degrees and pi over 2 radians. Now, we can keep going. Any of these big gaps are going to be 30 degrees, and any of the small gaps are going to be 15 degrees. So that's how I'm calculating these in my head, is I'll take 90 plus 30, and that gets me 120, so this is 120 degrees. This would be 120 plus 15 would be 135, and then 135 plus another 15 would be 150, and then 150 plus 30, 30 would be 180. So as far as radians are concerned, this one's going to be 2 pi over 3. This one is 3 pi over 4. This one's 5 pi over 6. And this is pi. So there's a whole bunch of different ways to remember the radians. One way to think about it is that I could draw, maybe. Nope, I can't. Because I left this plugged in. Anyway, I could draw another line that looks like this right here. And let's pretend that split that in half. Each of these would be 15 degrees. So this would be pi over 12. So technically, the unit circle could be split up into a whole bunch of pi over 12s. But that makes it a little confusing. It's just too many. And this isn't the sine and cosine of pi over 12. It's not really nice. But that would mean this is 2 pi over 12, 3 pi over 12, 4 pi over 12, 5 pi over 12, 6 pi over 12. And each time, if you count every 15 degrees, each of those will reduce to pi over 6, pi over 4, pi over 3, pi over 2, 2 pi over 3, 3 pi over 4, 5 pi over 6, and pi. So that's just one way to help you remember it. I don't want that anymore. Cool. And let's do this. So continuing, this 180 plus 30 would be 210. 210 plus 15 would be 225, and maybe a little bit easier, what you could notice is that 30, 60, 90, 120, 150, 180, 210, those are all multiples of 30. So you can kind of think multiples of 3 and then add a 0 at the end. So this is 3, 6, 9, 12, 15, 18, 21, 24, add a 0, 27, add a 0, 30, add a 0, 33, add a 0, that's not a 0, that's a 0, and 36, add a 0. And we just missed the 15 degrees, so this would be 315. As far as the radians are concerned, the way I think about it, this is 6 pi over 6, so this is 7 pi over 6. This is 4 pi over 4, so this is 5 pi over 4. This is 3 pi over 3, so this is 4 pi over 3. This is 2 pi over 2, so this is 3 pi over 2. Then I can kind of work backwards. This is 6 pi over 3, so this is 5 pi over 3. This is 8 pi over 4, so this is 7 pi over 4. This is 12 pi over 6, so this is 11 pi over 6. And this is 2 pi. Guess I should have started with 2 pi, but I forgot. So yeah, pi and 2 pi are really the easiest to remember. Then the others kind of fill in as you go. Anyway, those are the radian measures. Now we can talk about these coordinates, the coordinates at this point, and this point, why those important. Well, we really do need to know, if we're going to be talking about the unit circle, special right triangles from geometry, specifically the 45, 45, 90, and the 30, 60, 90, which we're going to use twice, 2 different ways. If we were to draw these triangles inside the unit circle, the hypotenuses, I think it's hypotenuses, or it doesn't matter. The longest sides of these right triangles are going to have a distance of 1, because these are going to be inside the unit circle. So if I draw this triangle, that's a 30, 60, 90 triangle, and I don't want that drawn in there. So the hypotenuse of that triangle would be 1. So if we did the 30, 60, 90, keep in mind that a 30, 60, 90 triangle is half of an equilateral triangle. Terribly drawn, but bear with me. So if this side's 1, this whole side's 1, which means this is a half. And then we can use the Pythagorean theorem, but I'm not going to use that because I know that if this is a half, this is the square root of 3 over 2. Because you just take the shorter leg and multiply it by the square root of 3 to get the longer leg. In a 45, 45, 90, you take the hypotenuse and divide by the square root of 2 to get the leg. So this would be 1 over the square root of 2. However, that's generally not liked because we don't like having the square root of 2 in the denominator, so we'll multiply this, or we'll just say rationalize the denominator and get root 2 over 2, which means this leg is also root 2 over 2. Neat. So we have all these legs. Now, as far as these legs are concerned in the unit circle, the legs are going to be distances on the x and the y axis. So for this first 30, 90, 60, if this angle is 30 degrees and this angle is 90 degrees, then this triangle will have a long leg of square root of 3 over 2 and a short leg of a half. But as far as the coordinate system is concerned, the long leg is on the x-axis, so the x-coordinate would be square root of 3 over 2, and the y-coordinate would be a half. And then for this 45, 45, 90 triangle, both of the legs would be square root of 2 over 2. So the x-coordinate is square root of 2 over 2, and the y-coordinate is square root of 2 over 2. For this 60-degree angle, it's almost exactly the same as the 30-degree angle, but it's kind of flipped. So now the x distance would be the small leg of the triangle, which would be 1/2, and the y distance is the square root of 3/2. So we have one quadrant done, and once we have one quadrant done, we really have the rest of the circle done. Why? Because the second quadrant is pretty much a mirror of the first quadrant, only the x-coordinates are negative. So if I'm looking at this point, let's say this pi/6 angle is going to be the exact same as 5 pi/6, except the x-coordinate will be negative. So this angle would be negative square root of 3/2, 1/2. This 3 pi/4 would be negative square root of 2/2, square root of 2/2. And this last one would be negative 1/2 positive square root of 3/2. So what I'm doing is drawing lines. Ooh, pretty. I'm kind of going directly across. So this point has the same coordinates as this point, except the x is negative because I've crossed to the y-axis, so now the x-coordinate's negative. This point will have the same coordinates as that point, but again, I crossed the y-axis, so the x will be negative. I can do the same thing going vertically, that in quadrant 3, both the x and the y coordinates are going to be negative. So now I have, nope, put that down, pick that up. Negative square root of 3/2, negative 1/2 for 7 pi/6. And then for 5 pi/4, I'd have negative square root of 2/2, negative square root of 2/2. For 4 pi/3, I would have negative 1/2, negative square root of 3/2. And in quadrant 4, I could look at either the first quadrant or the third quadrant and either mirror the first quadrant down or mirror the third quadrant over. Either way, in the fourth quadrant, x is positive but y is negative. So 11 pi/6 would be square root of 3/2, negative 1/2. 7 pi/4 would be square root of 2/2, negative square root of 2/2. And 5 pi/3 would be 1/2, negative square root of 3/2. And that's all the coordinates on the unit circle. And that's sort of one way to think about it is once you have this first one, you can figure out the rest of them by mirroring them around, thinking about which x and y's are positive or negative. And then also, so if I'm given a blank unit circle and I want to fill it out with degrees, radians, and all the coordinates. The degrees start at 0, and then it's 30, 15, 15, 30, 30, 15, 15, 30, 30, 15, 15, 30, 30, 15, 15, 30. I'm back at 0 or at 360. Those are the same thing. For radians, I can think about pi/12, and every 15 degrees is a pi/12, so I just reduce all of them. Now, if you use pi/12, you have to keep in mind that you'll have to put a sort of a dummy radian in between every 30 degrees, and then just reduce everything, and that'll give you the right ones. As far as finding the coordinates for this first quadrant, just think about your special right triangles. These, the 45, 45, 90, and the 30, 60, 90, and you should be good. That's the unit circle.